Hi, this is Adam from Small Town Machine Shop with the intro video to the homemade rotary phase converter series. Now what I'm going to do in a series of videos is take this 15 horse Dayton or Baldor motor and turn it into a rotary phase converter. I'm going to show probably 3 different setups. There'll be 1 video a week on this. And I mean, from the very simplest, like I could carry this over there, hook it up and have it running in 5 minutes to power a machine. And then we'll go a little fancier, and the like. Now, whether you need a rotary phase converter varies on a lot of things. If you have a lot of different motor voltages, or horsepowers, in your shop, it's a good way to get by that. If all your motors are smaller, you can wire a outlet after a VFD. And if all your motors are really small, like 1 or 2 horsepower, that's a really cheap and effective way to do that. You just wire it up, put long cords on everything, and there you go. The motors in my shop range between 1 to 7. That's why I went with a 15. And a few of my machines came with static phase converters. Now what those do is you can just wire them up. They're attached to each individual machine. And they're wired up, and you don't get full motor power out of them. I had a big Axelson lathe, and I used even an overrated static converter. And when I had my, I think it was a 14-inch chuck on there at the high speeds, it wouldn't turn the motor. So they have their limitations. They're cheap. They're readily available. They're good on woodworking equipment. I know a lot of people with woodworking equipment that use them. So this motor, I'll be using, again, a 15 horse Baldor. I recommend using a good name brand motor or a really old motor. I've probably built 30 rotary phase converters for people over the years. The really super cheap, like Chinese 3-phase motors just don't last, and I really question the horsepower rating on them. That might be like peak for a fraction of a second horsepower, but there's a noticeable difference in them. If you can find, like this motor here, this is good for inverter duty. These make really good phase converters. They run cool. Inverter motors, if you don't know, they're kind of designed for running off VFDs where the motor speed isn't going to be 100%. The cooling on a through-cooled motor intends for it to be running, at its set RPM. And, the fan is designed for that. Airflow is. These have a bigger fan. They almost always look like this, where they're ribbed on the outside. So these are a lot better at staying cool overall, and even at the low RPMs, like if you had a VFD hooked to it. But because of the, when you use a rotary phase converter, if you don't know, they're not as efficient. You don't get the power usage and heat buildup and stuff is going to be less, will be more than if you were using it straight hooked up to 3-phase. So if you can get motors that run a little cooler like those, then that helps out a lot. Now, most of the converters I've built have been within the 10 to 15 horsepower. You can make them really small. I made a converter once. A guy had a fractional horsepower, 2 fractional horsepower 3-phase motors, and I made it out of a 3-horse one. That was a pretty small converter. But generally, most of them are 10 to 15. You want to size them about twice the horsepower of the motors you intend to run. With these earlier setups, where you start it with really crude methods. The third leg isn't as constant, of course, as the generated leg, I mean. So it's not real conducive to, CNC equipment, stuff like that. It gets a little better if you have a good difference between the motor, your idler, and the motor you're running. The closer you get to the extremes, it really shows. I got a buddy with a small CNC mill. It runs a 5-horse motor. Is the biggest horse motor on it. And he had a 10-horse converter. And it was really choppy. You could tell something wasn't right. We put a 15-horse on there. And of course, it still wasn't right on, but it was noticeably better. So that's something to think about too. And when I do the bigger builds with the switches and capacitors and all that, I'll give you the actual part numbers and everything I'm using. Of course, that'll be scaled to the horsepower of motor you're using. That's another thing to dictate. If you're in an area where motors don't come cheap, VFDs and stack converters might be the thing for you. I got this brand new 5-horse motor at an auction. The auctions around me, that's a $40 motor. I paid more for this because I knew where it came from. I knew the history of this motor. And I wanted at least 15 horsepower motor for the shop. So if in your area motors aren't really accessible or reasonably priced, you might have to go with something else. So there's a few factors to think about. I like rotary phase converters. I have nothing against VFDs. I've had them on a few of my machines. They're, especially if you want to run like a 3-phase welder, a VFD is not going to work for you. They're really not designed for that kind of loads. Especially the instant, strike in the arc stuff. It's really, really, really bad for them. These are okay. I've ran a 3-phase welder off my VFD. Not my last one, but the one before that. And then another thing with VFDs is sometimes they just quit. A motor will give you signs that something's amiss. So that will be the upcoming series here. Again, I'm going to go in pretty detailed in each video. Again, it's going to be, I'm not a certified electrician. I'm not an electrical engineer. I've built a lot of these. I understand the principles of everything, but, this is all at your own risk kind of stuff. So just be mindful. Be mindful of wire size. Be mindful of breakers, your connection points, stuff like that. A lot of people, and I've seen this before, they use a small motor, but they think everything has to be really high. They really, really, really oversize the wire, and particularly the breaker. So then when there's a problem in the motor, it just toasts the motor instead of popping a breaker. So we'll talk about that a little bit. Again, I'm not an electrical engineer. Just go off the tags on the motor and, use that as a basis. So yeah, that'll be the intro to this series. And look for the first video coming up. This is Adam from Small Town Machine Shop. Please comment, like, and subscribe, and thanks for watching.